Welcome to the Meltzone podcast. This is episode 53. I'm Tom.
And I'm Stefan. And on today's episode, we are, chatting a bit about the physics of my DIY high-flow version of Bondtech CHT version, and if these are a real alternative to Volcano Hot End. Then I was kicked from Amazon, my threaded inserts, and I just talk a bit about the backstory there. Then, of course, Prusa XL was revealed recently, and we kind of take a look at the features and see if they are any good. And on the topic of features and being smart, Prusa XL has a cool new sensor that can basically measure the force that goes into a filament that's necessary for the extrusion. And another company called Bond3D uses kind of a similar approach to make basically perfectly dense parts out of a peak polymer. And we just chat about if something like that would also be implementable on a smarter printer like the Prusa XL.
And sticking with the topic of stuff that Prusa has done, now Creality are also doing a multi-material upgrade. Well, actually, it's a third-party company, but Creality are endorsing that as a multi-material to Naka for their own machines. Lastly, we do answer some questions in this episode. First of all, a question from Twitter about a new 3D printing technology that uses individually 2D printed layers and whether that is something new or just a rehash of something we've seen before. Then a question about thermal fuses, whether printers should use them more or whether they make any sense at all. And lastly, a bit of a meta question. Do we make any money off of this podcast?
Tom, you just told me that you have finally been watching one of my videos.
Yes! Yes! I usually never watch other 3D printing YouTubers' videos because either it's stuff I already know or it's depressing because you're seeing how well others are doing with content that's like so sloppily done, shows and stuff. But yes, I finally watched one of your videos. The high flow DIY CHT nozzle. Should I call it clone or alternative, I guess?
Alternative DIY high flow nozzle. So it is also CHT, but I think CHT is a trademark.
What does it stand for?
Core heating technology, which isn't a bad name.
Yeah.
So, the idea behind the nozzle, or the problem of melting polymers is that they just have a horrible heat conductivity, and it just takes such a long amount of time, even if you're cranking up the temperatures, that sometimes it can happen that the core of the material is still molten, still solid, and the outside is molten, which coincidentally happened this morning when I baked my frozen bread, and I cut it open and I noticed, all right, on the outside it's already crunchy, but the core is still frozen.
You were baking. You were heating up frozen bread.
I kind of always do that.
Okay, no. It's not that that's a bad thing. Use the microwave. Works really well. So for the bread that I bake, I usually cut it into like one serving portions and chuck in the microwave for 50 seconds. And it's perfectly fluffy and soft and nice again.
Well, I do have Aufbackbrötchen. What's the proper English word for Brötchen?
Rolls.
Rolls, yeah.
Depending on where you're from, but yeah.
And you gotta bake them in the oven because otherwise they're just a mushy mess when they come out of the oven. So yeah, that's my morning routine, baking my frozen rolls, and on the weekends frozen croissants. I don't know.
Hey, that's fine. It's fine if you like it.
just a thing that I do. Well, same problem here. You're heating the roll from the outside in, and even if you crank up temperatures a lot, it can still happen that the core is frozen. And that's the same thing with the core heating technology. So with a nozzle, They are putting just metal parts on the inside that they might have the chance to heat a filament from the inside out and from the outside in, effectively giving you higher melt capability.
Yeah, you get more surface contact area of your hot nozzle geometry with the filament, which it's coincidentally is also the reason why 1.75 heats better than 3mm. Have you tested that?
I have not, because I think only my Mendel 90, which I converted to 1.75 years and years back, still has the capability for 3mm filament.
Ooh, that's
but Tom, the thing is, if you're printing at the same extrusion rates, 3mm filament will stay longer in the heat zone or in the melt zone.
Correct.
So this is an effect that can go in both directions.
Yeah, from what I know, I think Ep53 have done some research on that a couple of years ago, and they did find that 1.75 does effectively allow you to print faster with the same nozzle length. Even though, yes, as you're correct, the filament stays, 3mm filament stays in the heated zone of the nozzle longer, but because conductivity is such a big problem, you end up with less heat transferred into the filament or into the core of the filament.
Yeah. So it is not only surface area, as you just said, it's also the distance from the outside to the center.
Right.
And before making that video, I talked to Carl, who is the owner of 3D Solex, who is also the patent holder of the core heating technology. And he said that the effect of the core heating technology with 3mm filament is even higher as with 1.75. Yeah. I think one of the reasons is, of course, the distance to the center, and also that the thin bores that you have in a nozzle, they restrict flow quite a bit just by flow resistance when the polymer is really flowing through the part. And when you increase the diameter, also the drag in the nozzle decreases, and that might be also one of the reasons why this is better. I haven't really investigated that yet, and I think for the moment there are rarely any, besides Ultimaker, there aren't any like
Ep53.
Do they still have 3mm filament also on the Sigma?
Yeah, I used the Sigma D25. I tested that a couple of weeks ago, and it still uses 3mm filament.
Okay.
That's the only option. You cannot get them as 1.75.
Yeah.
And
Lul
spot. Yeah, I was going to say you get the option of using 3 or 1.75.
Yeah.
But other than that, it's all 1.75 anyways.
I would say like the market share when you take a look at filament production.
Oh yeah,
I can't say. Sure. I maybe need to ask one of my contacts, but I would bet that the market share is maybe 10% or even less.
Yeah. For
3mm filament,
you might get an offset there, because the people who buy 3mm filament, 3mm printers like Ultimakers and Sigmas, they really use those printers and they have very little idle time. But overall, yeah, I think you're onto the right number there.
Yeah.
So yeah, essentially,
and looking at, sorry.
Sorry. Essentially, what you're doing with the CHT is you're splitting that filament into 3 smaller strands. So if you had a 3mm CHT nozzle, those bores would be roughly 1.75 as far as I know, because the surface area is 3 times as large. So, yeah, you were going to say something? Not anymore. Okay.
What did I want to say? Not anymore. Forgot it.
So you DIY'd that with just soldering in some copper wire through the nozzle crosswise, and then you made up for the flow restriction by widening that bore. So you tried 0.8mm wire. Have you thought about using thinner wire with that?
Yes,
just to
I
restrict
do.
The flow risk and more wires inserted.
I just did not have the time yet to try out all of the options. I would really like to do like a big DOE comparing the number of wires and also the diameter. Looking at the CHT nozzle, for example, the part where heat can really conduct from the outside in isn't that big. So I guess the conductivity of the metal isn't a problem, which would also mean that you could work with thinner wires, and those thinner wires still have enough heat conductivity to put that heat into the center of the part, because in the end, polymer heat conduction is by a factor of like 2 magnitudes lower than brass.
Yeah. So it doesn't matter if you're using brass, copper, or which thickness of that metal you're using. You're still going to be limited by the polymer.
Yeah.
Yeah. Well, this is something that I've thought about a couple of years ago already. Like, what happens if you like machine the inside of a nozzle of the threaded part? You have it split in two, you machine like a star-shaped pattern into that, and then you braze them together and braze like the hicks on the bottom, just to give you maximum surface area. But like I said, the penetration into the filament, into the polymer, might be a bigger factor there.
Yeah. So what I really want to try out is, what's the English name for Räumen? So the tools that you're using, for example, to add a hex pattern into
broaching.
If you do broaching, I have been buying Torx brooches, because with Torx you have that star pattern. And I think a Torx 6 has an internal diameter.
Torx 6 is tiny.
Is tiny, but like the internal diameter is then still like 1.2 millimeters, and the outside diameter is around 1.82 millimeters. Sorry, no, it's I think a little above 2 millimeters. No worries.
Let me grab a Torx 6, because I do happen to have a full bit set here.
Oh. And yeah, just take a, like, well, you can't really take standard nozzles. You need to have one that is not drilled.
Is a Torx 6. Wow, focuses.
So it's in the right size dimension, or in the right size range. And the question is if the increase of...
Come on.
Does it work?
There
we go. Yeah. So the outside diameter is, I think, a little bit above 2 millimeters, which makes it, I think, kind of suitable for that application. And with the increase of surface area that you're having, is this also already sufficient to improve the melt behavior?
2 points
would be really interesting. 2.05, so yeah. Then you have Torx 8, which is just a little bit higher, so there's some variation where you could vary parameters. And the thing is, of course, you could cut into 2 parts a nozzle and then machine it from the inside, but that's not really something that you would do on an industrial scale. Yeah, 2.442. That's still totally working well for nozzle applications. Because cutting them into different parts, brazing them together, or as I did it, just like drilling them and adding wires and things like that, this is not something that you would do on an like industrial scale.
If you have like an $80 premium enthusiast nozzle, like the Ruby nozzles or something, if you go into that market, yes, maybe, but it's not going to be any sort of a volume product.
But the nice thing about Bondtech's CHT nozzle, they're selling those nozzles for $20,
which is really good. That's less than a Slice Engineering standard nozzle.
Exactly. And this is one of the reasons why I find this design so nice and so competitive, because it is not something where you have a big paywall. If you have a proper CNC lathe or 5-axis milling thing or whatever, you can produce those parts automatically without any manual intervention. And for this reason, they can sell those nozzles for $20. So, and if they're selling them for $20, manufacturing costs them $10 or even less than $10.
Probably less,
and they're even nickel plated.
I was going to ask that, like they look like they're plated with something, because they're
nickel
brass based material, right? Okay.
Yeah.
That's really good. I did not expect Bondtech to make such an affordable product, because typically they are in the premium market. Their stuff is rather expensive.
Yeah. But I guess this is one of the reasons why the nozzle is currently selling so well. Of course, after my video, they have been totally sold out pretty quickly. But I think they're still selling those nozzles very well. And I think it's a nice product just because it is affordable. It doesn't cost you 50, 60, 70 bucks.
It's less than an upgrade to a Volcano, right? So, and it gives you comparable performance. Now, the question is, are there downsides with using a CHT versus using a standard nozzle? Would you see the CHT as just a universal drop-in with no downsides?
For the moment, honestly, and I was really looking for reasons to stay with a Volcano, I haven't found any downsides of the CHT. Besides, of course, material compatibility, because these nozzles are not wear resistant, the CHT ones. Yeah. So you can use them for like glow in the dark or fiber filled materials. But besides that, they have a higher possible flow rate than a Volcano nozzle. They ooze less because there's less material heated in the nozzle.
Yeah.
The hot end is shorter and is therefore not so prone to vibrations and all of that. I didn't really
heat
find
break doesn't get as much load as with the longer nozzles and heater blocks. So it's really just a straight up upgrade.
Yep. In my opinion, yes. And well, I honestly felt a bit bad for E3D at that point because am they now taking market share from E3D? But yeah, I think that's just development, and I see this as a really nice innovation I was hoping for ages.
Yeah. Feel bad for E3D. Yes, they're people. Sure, they're people, they're a company that they've been with 3D printing for a long while, but when there's a product that is just better than what's out there, like why would you feel bad for the others? E3D are innovating too. They're putting out the Revo and stuff, but it's going into a different direction, and more good options is always good. There's always the talk of more options is better, but if like your alternatives are worse in some ways, that's not worth anything. But if you have some other option that is either universally better or just better in one specific way, like I'm all for that. Of course, the CHT is patented, but that's but so is E3D stuff. So
yes,
that's good.
I guess it's nice. It's really nice to see that innovations like this are still happening in FDM 3D printing, where many said for years, okay, FDM 3D printing is dead. It's all just NL3 clones and things like that. But there are things happening day in, day out. CHT nozzle, I find it really nice. I just have the 0.4 millimeter version installed on my machine, because before they didn't have a 0.4 millimeter version, because they said, okay, CHT is for high flow printing, and usually you are high flow printing when you have a bigger nozzle installed. So they had 0.6 up to 1.8 millimeters.
Honestly, 0.6 is fine. Is totally suitable for most stuff you're going to be printing.
Yeah.
You're going to be printing the exact same detail, almost the exact same detail, but you're going to save so much time with a 0.6. Now, looking at the Voron behind me, my 2.4, what do you think would happen if you put a CHT into a Mosquito Magnum Plus? Because that thing already screams. And do you think it would make a difference, or is it just what's it called?
I think only like really on the high range. I don't have like a section view of the Magnum.
It's all straight.
Magnum Plus. It's all straight.
It's a huge copper block at the bottom with a standard nozzle in there.
Yeah. So the thing is, and this is something I also found during my comparison, is a longer melt zone. Yeah, it's nice. It helps that the material stays in the melt zone for longer, so there's more time for just the energy to get to the core. Yeah. But the downside of a longer heat zone is also that it adds drag in the extrusion path, and that also limits flow rate again.
Yeah.
So adding a CHT, of course, you can push it even more. But I think and this is what I have seen, a 0.6 millimeter nozzle in a standard heat block can already give you 60, 70 cubic millimeters a second. That's what the Mosquito Pro Plus, or whatever it's called, can do.
Yeah. Yeah. And at that point,
a really affordable price.
Absolutely, yeah. I mean, the Mosquito Magnum Plus is what, $400 roughly. It's pretty crazy. So yeah, at that speed, you are already running into kinematics limitations. Like almost no printer can handle that sort amount of flow. That sort of flow. So yeah.
Of course, but we see more and more Core XY printers coming onto the market. We'll talk about the Prusa XL later.
Yep.
Kinematics is one thing. If you have a bigger nozzle, kinematics aren't
true.
Kinematics
if you're increasing flow rate by wider and taller layers, yes,
exactly.
But what if you don't want to give up your 0.15 or 0.2 millimeter layer height? What if you don't want to increase that? Then you will need to increase linear speed.
Yeah. I guess the even bigger problem that I found out is cooling. You need to cool that amount of plastic, and especially with PLA, if you don't have a really, really good cooling solution. Of course, CHD, for example, gives you the option to print 2 to 3 times faster. But if your cooling solution is not good, it doesn't really help you because all your part just stays mushy all of the time.
Absolutely. Yeah. Maybe one last thing. Thinking about like how could it improve the Super Magnum Plus? You in your video of the DIY nozzle, you were talking about how you get dye swell and how the internal stresses of your molten filament are a factor when it comes to how stuff warps afterwards.
Yep.
In a Volcano Plus, God, I keep mixing these up. In a E3D Super Volcano or in a Mosquito Magnum Plus, where you just have a long straight melt zone, you still run the risk that your inside, your very core of your filament isn't thoroughly heated. There might still be a temperature gradient. That there most definitely still is. Do you think that with installing a CHD on the end of a Magnum Plus, could that relieve some of those internal stresses by heating it more thoroughly internally?
I guess, but I think that's just really if you're going to the limit of what your hot end is capable of.
Yeah, obviously we're going to the limit. Like everything else is figured out.
I find it a really interesting topic, and I have so much stuff I still really want to try out because it opens so much opportunities, especially just for, you don't have to go through all of the hassle of changing to volcano hot end and things like that. And the interesting part for me is figuring out the edge cases and how you can really distinguish if one is better than the other. Yeah. And of course, melt rate is easily measurable, but in the end, this is not everything. Of course, cooling and things like that, but internal stresses that are still in the material. And you definitely see that due to the melt swell of at the higher extrusion rates. This is another parameter that you can take into the equation and in the end say, okay, this solution might be better than another one.
Yeah, but even with melt rate, when you're saying melt rate is easy to measure, you're not, I mean, yes, you're measuring one thing, but the results might not be comparable. Like it might be able to melt it at the same push force, but your result might not be the same.
Exactly.
So yeah, lots of stuff still to investigate, and people are liking the content. So
yeah. Of course, that's probably one of the reasons why I also keep pushing it.
Absolutely. You'd be stupid not to. You enjoy doing that, you know. It's like what I said at the beginning of this episode. Like, hey, it kind of frustrates me seeing others being so successful with this stuff, because I always like I feel like I'm just looking at, okay, what do I need to do next? Oh yeah, this printer needs to be reviewed. Yeah, that topic I said I would do, and then you just come along and say, hey, yeah, this could be really cool. Let's just do that. I'm kind of mad at myself for not figuring out those interesting little pockets.
I don't know. I think I do have, I wouldn't call it a gift, but finding topics that are still niches, where I can, on the one side, do content that is interesting for a broad audience, but still add this additional value by going into the physics and just digging a little bit deeper than others. And I'm always happy to see when so many are watching the video that there is a huge audience for that also, like really technical stuff. Of course, I have to pack it in something that is spectacular and things like that, but that's just how YouTube works. And people are not mad about that.
Yeah, and finding that sweet spot where it's something that people can relate to, but it's still adding something that they've not seen. That is the absolute perfect spot. And you figured that out. You're probably going to pass me soon in subscribers, and I very much applaud you for that.
I think that's still going to take a while, but yeah.
Honestly, you're probably going to be at 400,000 quicker than I am. So
I don't think so.
We'll see.
Only if I would start with YouTube Shorts, maybe. No. Something. No, I decided to not do that, or I would be interested in that, but on the other hand, I don't know. I don't have enough time for that.
I've thought about. Shorts. I did short. 2 shorts. Yeah, I just tried the format for fun, just to see like what it's like to make that sort of content. But I've thought about having my editor edit down the content I already have to like a TikTok format or a shorts format. Just like have a short little intro that I record separately, and then just the main video like down to 30 seconds, because most stuff you can't compress. You're just leaving out a lot, but.
I thought about that as well, but the question is, how would you post that? Would you start with a Tom's Shorts channel? Would you post it on your main channel? Is it only something for TikTok, Instagram?
Yeah, YouTube's doing a pretty poor job generally recently, but also with like keeping the different types of content apart. So you have your regular fully edited produced videos, you have your shorts, and you have your live streams, and those 3 possibly reach a very different audience. And as a viewer, you can't really say, hey, I'm interested in the shorts, I'm interested in the regular videos, and I'm interested in the live streams. So I think there's not enough separation there. Would I do it in a separate channel? I don't think so, because I think the shorts are somewhat separated away, but I don't know. I don't know.
There is a ton of potential. Just look at Mars Gizmo, for example, Adrian. Yeah. It's crazy how I think I checked his stats today or something like that. Like he has as many views every day as I have like in a whole year.
Yeah, it's crazy.
But on the other hand, this is content. Yeah, of course, it's already a bit monetized, but it's not making like a ton of revenue compared to like normal views. And the thing that is always interesting, if you have channels that do a lot of shorts, but then do a regular video, and you see the ratio between normal views of a shorts video and views of a regular video that is for viewers that relate to the channel and find like the content, I think in general, interesting. It's always crazy because sometimes it's like 2 million every short video to like 10 or 15,000 for a regular video,
which is all right. Like if you've not built an audience for the regular videos, that is good for a normal video, I'd say. Of course, like you're doing like 200,000 views every video within 2 weeks, but like you've built your audience based on people who watch the normal stuff. Yeah. YouTube's weird. I don't think they know what they're doing. You know, removing the dislike button. That's why.
Yeah. Nobody understands, but it's
it's obvious. YouTube's goal is to have people spend more time on the platform.
Yeah.
What better way to have people spend more time on the platform when they have to dig through a dozen videos to find the one they actually want to watch, the one that's actually good, like tutorials. I think we've talked about this before. I don't watch tutorial videos if I'm actually looking for a solution to a problem. I watch Blender tutorials and stuff for fun. But when I want to learn how I do something in Resolve or in Affinity Photo, I go to text articles because I can scroll through them. Somebody tweeted about that where it was like, okay, when I want to find something, I want random access information where I can decide where I want to pick, and not sequential access. I don't want to watch, or I don't want to listen to a tape audio cassette for, where it plays start and then it plays linear like in a video. I want to be able to look at this stuff, and I don't know why I'm even talking about this, but yeah. Just a
because not having likes makes it hard to filter between like good content and bad content. Because if you're going on a tutorial which has like 2/3 downvotes, you already know, okay, something's wrong there. Let's look for another one.
Yeah. Anyways, you were kicked from Amazon.
I was kicked from Amazon.
What's happening there? Where are you doing? Like, we're gonna give you a €10 discount for a positive review, or what's that? That's like the classic.
Of course, that's what we did. No, I guess just like starting selling your own content comes with trap. No, not contents, your own products comes with traps. So, we were selling our threaded inserts on Amazon, and they were going really well, and people liked them, especially, for example, the 1/4" inserts for camera threads. Yeah. And then just one morning, the whole Amazon page was gone, and we received an email. More or less, somebody complained that there wasn't the whole address of the seller on the package, and this is against Amazon regulations. So you're kicked from Amazon.
On the packaging. So on the packaging of your actual product.
Bag. Yeah.
Okay.
So I guess the whole name and address needs to be on the packaging, and also the material of the packing bag that you can recycle it in the end. I'm thinking, and of course, maybe I'm a bad person there, but of course, we were not the only one selling threaded inserts, and one of the competitors saw, okay, this guy is now also getting into the business. Let's see if they are doing everything right.
Of course.
And they kicked us. Of course, we didn't do that properly. I don't really blame myself, because that stuff is handled by my business partner, and he probably didn't research that stuff properly. And the problem is that, of course, we can now just relabel the packages and get everything back to Amazon, which we already started. And for example, the short insert sets are already available again. But we made the mistake of putting our whole inventory in the Amazon storage.
Right.
And the problem is Amazon is blocking those articles for the next 30 days that they can still fulfill pending orders and things like that. And only at that point you can say, okay, I want to have our products back,
right,
that we can relabel them and get them back online. So it's a whole month lost for just that phase. Now they need to send them back to us. Then we need to relabel them. Then we need to get them back to Amazon. That's basically 8 weeks of revenue lost due to that incident. And
unless you buy new stock, which you probably can't do as quickly, you buy new stock and refill their stock with properly labeled stuff.
But good luck currently getting products from China at the moment. But of course, I kind of understand that business practice, because, well, why are we doing everything right if they're not doing them? But I still find it kind of shady, and
that others are reporting you and you're getting kicked?
That somebody else just reported us, because who is.
It is it is how it is.
It is how it is.
Don't hate the player, hate the game kind of thing. I don't know if you're selling on Amazon. I don't know if I told that story where we're selling just used PC parts. I was selling a graphics card and stuff on eBay. I think I was selling like a 1070 or something. And another seller reported me. Well, they didn't report me, but they sent me a cease and desist with their lawyer. And they were like, well, you're going to pay us 450 euros for not including a clickable link to the EU, what's it called? Schlichtstelle.
Yeah.
To their, well, where buyers can complain and they take care of that. The link was there, it was just not clickable. It wasn't a blue clickable link. The text was there, but it was not clickable. And they were like, "Well, that's a crime, and we're not gonna sue you. But we're not gonna sue you if you pay us 450 euros. We're not gonna sue you for unfair competition or whatever it is." So. I was like, well, what are you going to do? I asked the lawyer myself, and they were like, well, you were in the wrong, they were in the right. Deal with it. It is how it is.
Yeah,
and
it's interesting. I understand it. There are regulations that you need to comply to, and it's good that most of these regulations are there, because that makes products safer, that makes recycling safer, that makes many things better for the consumer.
The playing field, right?
Yeah. But still, if somebody would be really mad, they would have sent us a cease and desist. If it would be just a competitor, it's of course way better for them if they kick us from Amazon for 8 weeks, because that's 8 weeks more for them selling their products, and 8 weeks less.
You having a lot of extra work now, so
yeah, it is as it is.
And plus, if you sell on Amazon, you are Amazon's. Yeah,
we are currently actively looking for other resellers. Amazon, on the one hand, is really nice because they handle all of the distribution around Europe, prime shipping. They are on the one hand cheap, but on the other hand, with prime shipping comes, of course, the shipping part is kind of taken a bit from your cut. So if you are, I don't know, selling a product for $20, Amazon is still taking like $5.
Can you publicly say that, or is that like non-public information?
I actually do not have the right numbers, because my business partner is responsible for that, and I'm just hoping for a big paycheck at the end of the year. But yeah, the problem is that also you gotta deal with these problems, and Amazon is kind of hard. So for example, you have the responsibility, if somebody is posting a question under your product, you have to answer within 24 hours. If you don't do that, your article is gone.
Oh, really? They delist you?
Yeah.
Wow.
I don't know if they directly delist you or if you're getting a strike and things like that, but yeah, that's happening. So they're really strict. If you have ever asked for an invoice for an article that you purchased, this is also one of the reasons why you always get those invoices within a couple of hours.
Okay.
Because if they would not respond,
it makes it that's something I can really understand. The thing with the question on the article is like, okay, sometimes people just ask dumb stuff and you still need to respond to that. But with an invoice, like I'm buying stuff for the company, for the business, I need an invoice. And if there's a seller on there that doesn't provide one, that's just like you can't tell before you buy something. So, yeah. There is a reason why so far, every chance that I would have gotten to have a physical product that gets sold somewhere, I didn't touch that with a 10-foot pole. Like I was like, okay, physical product, too many pitfalls, too many responsibilities. I'm thankful that you're going through these right now and you're figuring that all out. But yeah, I know it's hard. It's the reason why I've never done it.
And I can just recommend that you at least have somebody who's looking for that stuff, because doing that in video production at the same time is just killing you.
Exactly. I was going to say that, like, you cannot do that just as a side thing. You're already well loaded with you already have plenty of a workload with your regular stuff, and then just adding that on top. Yeah. physical products. A big physical product. Biggest.
A really big one.
Is it the biggest physical product they've made yet? I think it is. The Prusa XL. If we don't, I mean, if we discount the printing center they showed in Dubai. But yeah.
So
Prusa
yeah,
XL.
next topic.
Yes. If sorry, listeners, viewers, if you didn't notice that. We're moving on to the next topic. The Prusa XL is now officially announced. It's not out yet, but it's been announced and it's been shown, and it's going to happen. Q2, Q3 2022 is when it's shipping. What do we have?
Core XY. I think it was the obvious choice.
Yeah.
For something like that.
But
direct extruder?
Core XY in a way where we have Core XY on top and then the bed moves down. So Core XY, static XY, and then the bed is just moving on the Z-axis. Unlike, so what is that like, Voron 1?
The, this is not Sidewinder,
that's an artillery printer, that's a different machine.
Yeah.
2.4 has the entire toolhead moving with the bed static and the Prusa
switch wire. Switch wire.
Okay. Yeah. Yep. Core XY. 36 centimeters cubed.
Yeah. Pretty big. Even compared. So obvious comparison is the tool changer. E3 tool changer. It has 200 by 300 by 400 or 350.
Don't know.
Voron, the usual Voron 2.4s. Of course, you can build them at different sizes, but usually people are building them with 300 or 350 cubed.
Yeah, 350 is the bigger size, so you can build them 250, 300, 350. Mine's 300.
Okay.
And it's a pretty large machine. So thinking about like this would add another, 50 millimeters. It's quite a substantial machine, the XL.
Yeah.
It is using a heated bed that has 16 segments, so it's not one large bed. It is using individual 9 by 9 centimeter segments that not only they can turn on and off individually, but they can also regulate them individually, as far as I understand.
Yeah.
So if you just have a smaller print, you're only heating up a section of the bed, which saves, I mean, with a bed that large, that saves a significant amount of energy in the end.
Unfortunately, we didn't talk about that before they released it, because I have been thinking about what could be like the new big Prusa innovation thing for the XL. And one of the things I always thought, okay, if you have, or what I'm always upset about if I have such a big machine is the big heated bed. And if you're not printing big parts on it, it just heats up your room, uses a lot of energy and things like that. So I actually would have bet on a bed that is like where you have a variable heater size. I would have suspected, and I can't remember where I have seen that before. I would have suspected maybe like a 2 heater zone thing, like you have one heater zone in the middle, which is 200 by 200, and then an outer one. But the solution they made now, I really like.
Yeah. So on variable heater sizes, my Metal 9000, it's actually behind me there, used to have a double heater. So the old 214 millimeter, actually also designed by Prusa back then, heater PCBs, I had 2 on those side by side, and I could turn on individually each one. So I could do half the size, or I could do double the size and just save power like that. The problem, of course, if you stitch that together, and the problem you have with PCB heaters in general, if you don't support them well, is they bow because of thermal expansion on one side's a bit hotter than the other. And on that heater PCB on the Mendel 9, I don't know what it was calling back then, I could measure as much as 0.5 millimeter of flex easily as the printer was heating up. And then as the PCB was, or the heat was regulating, you could still see it bounce up and down. So during a print, your entire print would basically bounce. The hot end was okay, but the print underneath it would move around. So that's something that they're saying they are solving by not just having one large heater that has a center zone and an outside zone, because they could have done that too with a PCB, but by actually splitting it into individual non-connected little bits.
And if they have 4x4, that's 9 centimeters by 9 centimeters, which is a really tiny and I think nicely manageable size, and I think a very good solution. It makes the thing really complex because you have 16 thermistors probably. You, I guess, probably have a distribution circuit with MOSFETs below the bed because you don't want to wire each bed through the cable chain. And what I have read in here but not totally understood is you can't like just say, okay, I want this and this and that grid activated. There is some kind of a pattern involved. I don't know if they're doing a multiplexing thing. So as I have understood it, you can't just say, okay, I want the 4 squares in the middle activated and the rest are off. I think you have to do line by line or something like that, or in a specific
segmented. They're saying it is individually controlled 9x9 segments. No, I don't know. The video I think suggests that you can really individually turn them on and off, but it's going to be handled by Prusa Slicer, I assume. That Prusa, it would be handled by Prusa Slicer. Yeah, that it automatically detects. Okay, your print is covering these areas. It is that close to the next one. Okay, we need to turn that one on or off. And that should. It's relatively trivial. So yeah, heated bed, great thing. Reading out thermistors, multiplexer, yeah, no big deal actually. And then controlling them, you just add an extra microcontroller, like on some small 32-bit, whatever, costs pennies, if you can get them. If you can't get them, they're like $15 each. But yeah, so that's the heated bed. That is really great to see. Of course, it's not a necessary feature. It's just hey, we're going to save some energy. We're going to save some heat buildup inside the machine. You don't have to have a segmented bed. You could just chuck a 2 kilowatt bed in there and say, hey, we're going to heat the entire thing every time. But hey,
of course, it's a feature. I think it's a nice feature, and also it goes into the right direction. But the argument with the less distortion due to the individual segments, I guess, is a valid point where you could say in the end, okay, I need less mesh back compensation.
But you could do that without controlling every single one individually, I guess.
Yeah.
If they're close enough in heating power, you could just wire them in parallel.
Daisy chain them.
Or series, whatever. Then they've got the Nextruder. So the Nextruder is an extruder, so filament pusher, that not only uses a new gyroid gearbox that has a, what is it? Do they say what gear ratio that they're using?
1:20.
1:20. So typically you have like a 1:3 or 1:3 point something gear ratio on your typical Chimeras or Bontecs or whatever. 1:20. So your extruder stepper motor is going to be spinning really fast in this one.
No, it won't.
It won't?
It won't, because the extruder gear is way bigger.
Oh, you're right. You're right.
Yes.
Haha.
And this is the interesting thing. So if you just scroll a little bit down in the on the blog post, you can see that the diameter is, I would say, around 50 millimeters, 40, maybe 40, 30 millimeters, something like that. Way higher than the standard. I think the Bontec gears have 8 to 12 millimeters, something in that direction. Ballpark.
Yes. If we need to be precise here about the Bontec gears, because there is the Bontec gears and there is the Bontec LGX gears. And the LGX is Bontec's large gear extruder, which obviously Prusa are emulating here with that gear. I don't know if they're using gears made by Bontec. They were using genuine Bontec wheels with gears on the Mark III, but this is basically that concept. So with a larger wheel, of course, you get a larger contact patch on the filament. So you're not just concentrating your drive force on one or two teeth, but you have more teeth engaged at the same time. And what they're also doing is, so it's only driven from one side. So you don't have the dual drive side, which what was that? Issue 100 and something, the inconsistent extrusion on the Mark III.
Yeah.
So you're getting rid of that. That's not a thing anymore. But what they're doing is they have an idler that pushes against that wheel, but they have two bearings in there. So you have not just one contact patch, but you have two contact patches against that wheel. So you're again doubling the contact of the drive wheel with the filament.
Yeah. This is actually something that is worrying me a little bit.
Because you're
I'm happy that bending the filament, yeah. I'm happy that Prusa, that they have their carbon fiber filled piece polycarbonate blend, but especially with either carbon fiber filled materials, they are sometimes a little bit brittle. But then there are also other materials like PVA or, I don't know, special filaments, wood-filled ones, and things like that, that tend to be a little bit brittle. And I do fear a bit that this could become a problem.
Yeah, it looks like they're putting quite the bend on it, because they are conforming the filament to that diameter of the drive wheel. And like you said, the drive wheel is like 40 millimeters, so you're basically bending your filament in a 20 millimeter radius. Yeah. Which you can't do with many filaments without it actually either snapping or permanently deforming. So I would assume that either that there must be like a single idler wheel option, right? They can't force everyone to use the double wheels. I can't really say it from the picture, but maybe you just have to replace the idler arm. But then you run into the problem again that you only have a single-sided extruder, which works. Should still give you the same contact patch or better contact patch area than on a classic dual drive system.
Yes, of course, just due to the diameter, and more of the gear is just engaged with the filament. But still, this was one of the things I said, okay, yeah, nice option or nice choice there with the, what did they say, zero backlash cycloidal gearbox. But bending the filament that way, I think that might be an issue for some materials. But we'll see. I hope they do their engineering properly.
Yeah.
I would expect that.
Prusa does like to live on the bleeding edge a bit more than others. I'm trying to see how cookies off. Trying to see how Bondtech actually does it on the LGX.
They have two of these big gears.
Yeah. So the LGX is still a dual drive extruder. Okay.
Exactly.
Right, so you have the next extruder with the large gear, with the cycloidal gearbox. You also have a load cell in there that measures whether you have a clogged nozzle and filament flow, and that they can measure all that and either throw an error or correct for it real time somehow. Like we were previously discussing with it. Talking is hard today. With the flow rate decrease. Yes, exactly. You were measuring on that how much the flow decreases as you push faster. Maybe they're correcting for that, though the filament's not going to be heated well then, but maybe they're correcting for that automatically.
Yeah, they have the data now, and the question in the end is what you do with this data. But if you are processing it properly, there's definitely the option. And this is like the added smartness that I was really looking forward on those machines, because, well, the XL is in its cheapest version as a kit, $2,000. So this is not something that you buy yourself for a first printer. But if you want to do like serious, maybe higher production or high volume or big size printing, and you are happy for every bit of smartness that maybe pauses your printer when you have a jam or when the filament runs out, and all of these things. Because fails can be expensive, and with this sensor in there,
at that size, right?
Yep. And that smartness is nice, and they're also using the same sensor for nozzle, for bed leveling with the nozzle. So they don't have the pinda probe anymore. They don't have the temperature shift problem that the pinda had in its first iteration. They are doing the same thing as Creality did with their CR6 SE.
Yeah, exactly.
Yeah.
I think I keep coming back to this, but how is the Ultimaker 3 doing it? I think also with
Ultimaker 3 is doing it with a piezo electric sensor.
Okay, but
so it's
different sensor but same idea.
Different sensor but same idea. Yeah. And they've been doing it for years, and it works fine. I don't know how good it will work if you have one of these really rough PEI-coated pads.
Right.
But I find it a really nice solution.
I mean, what it can definitely do is just take multiple readings, just like move around by a couple millimeters in each direction and just get an average.
Yeah,
should be good enough. Or you can see like a min max and just pick the median.
Yeah.
Then the hot end on the XL, like what's it gonna be? Is it gonna be a Revo? Kinda. So it looks like from the video, though, that they're not really confirming what exactly that they're using right now, and that might change because this is still in flux. It looks like they're using the Revo heater core, so the ceramic heater that's on the Revo and that entire assembly, but they are sticking with traditional M6 nozzles. At least that's what I saw from the video. So not the quick change Revo nozzles, though if you look at what the filament path looks like at the picture where you see the large gear, the drive gear, it almost looks like a Revo or Hemera heat break sticking up into that. But it from what I can tell, it's the heater, but it's standard nozzles.
Yeah, I think they're also using the same, like the surgical needle stainless steel tubing, which is a really good solution for a heat break. I find it good that they're sticking with like the M6 standard, because if you have one of these machines, you want to use it with a vast range of different materials. So this still gives you the option.
Yeah.
I haven't really seen on the pictures if there's also kind of a, like Slice Engineering is doing a support for the heat break, that if you're changing the nozzle, not all of the torque goes through the heat break. Well, yeah.
Well, no, some companies give less or care less about the patents than others, but this hot end is engineered by E3D, so I would assume they would be respecting others' IP. In either case, it's not the Revo nozzle, it's standard nozzles. But of course, if you want to switch nozzles, you've got a tool changer in there too. So obviously, did you see this coming? Did you see did they kind of tease it, right? But would you have thought that they would build an entire tool changer on the XL?
If I would not have heard the rumors, I would not have expected that. Yeah. But since they have always gone a bit in the direction of multi-material or multicolor 3D printing with the MMUs, I think it's a good solution. I think it's okay that they did it, and I think it doesn't really harm the design that much, because you can still get the XL with just one tool, which is pretty cheap, and if you're paying $1,500 more, you're getting 5 tools all in all.
Yeah. So let's go through the prices real quick. What is that? VAT included? Why is there a $100 difference? Anyway, so the single tool head is around 2,000 euros. The dual tool head is around 2,500 euros, and the Penta toolhead is around 3,500. Oh, that's euros and dollars. Okay, 3,700 euros. So does the single still have the tool changer mount?
I was asking myself the same thing. Well, judging from the price difference, so they're charging $500 if you are adding an additional tool, and they are charging $1,500 for 4 additional tools. So I would think that this would be the case, because yeah, every tool is $500 more. That's crazy.
Yeah, that's quite a lot. That is a lot for an extruder. Yeah. I don't know how much electronics they're adding to it, but $500. $500. It's quite steep. You can get quite a few Chimeras for that, and add your own Do-It-3 expansion point with that as well. So
yeah. So I guess does it look that way? Can't really say. I would think that that you have the changing option even with like just the one tool head, just because that you don't have like different versions of the mounting system and things like that. But since the mounting system adds complexity and adds also, well, decreases rigidity, it might be a good option if you're just having like the one tool version to mount it directly on the carriage. Yeah,
they might have some dummy part in there to have the same geometry, but it just gets screwed together and is fixed.
If you're looking at the pictures, it seems that the sled is missing where the tool attaches on the one tool version. But they will be releasing the printer in like 6, 7, 8 months. Yeah. So there's still a lot to change there.
Stuff will definitely change until it's released. So pricing wise, I honestly would have thought it would be. I would have guessed it was going to be more expensive. So the 2,100 euros starting price for the single tool head, I thought it would be more expensive because, I mean, Prusa are always in the premium price tier. And if you look at what others are charging for printers of that caliber, it's still on the lower end of that price range. So what I like about this is that there is now a good, solid option for a larger printer. What printers are there that go to 36 by 36 by 36 centimeters?
I would have said Ultimaker S5 before, but it's not that big. It's just like 300 by 300. I think not even 300 by 300.
Yeah, the S5 fairly tiny for what it is. Yeah. The Sigma
of course,
printers?
You have the Sigma printers. Yeah. You have the DIY options with the Voron, but like a Voron in that size, as I said, Of course, you can go to not premium brands, but more professional brands. But then you are paying for such a machine in that range at least $10,000, $5,000 to $10,000. There is the Creality CR10500, and they have bigger options, but bed slingers at that size, that's. So what I'm regularly faced with is mostly like a company or a semi-professional user is asking, hey, I need to print large parts. What can you recommend? And at that level, you can't recommend a Creality. Like, no way. You can't put that in a professional environment and say, yeah, this is going to be our production machine that we can rely on. As good as they are. I mean, Creality printers, for what they cost, are amazing machines. But I would never put it in a pro environment. Stuff like the Voron. Fantastic machine. I love my Voron 2.4 that I'm holding on to right now to stretch my shoulder. Love that thing. But it took me 30 hours to build it, and you're on your own. You don't get any support unless you rely on the forums and Discords and stuff, but then it's still like you have to figure stuff out yourself, and you were the one building it, you were the one responsible for the machine. You don't get anyone else to blame anything on. So as much as the Warren, you can build it a good bit cheaper probably,
and it might perform better, but it's just not the same market. It's a different application. It's a different machine. So yeah, if anything, I mean, I don't know if the Prusa XL is going to be good. I don't know if it's going to be bug ridden or not. But if anything, it's going to open up that market. I think it's going to encourage more companies to get into the larger, proper printers, as I would call them, market. Because right now it's just super thin there.
Yeah. Well, not everyone has the necessity for such a big machine.
Oh, but it's really nice to have one that large.
It's really nice to have one that large, but that largeness always comes with a downside. Like, for example, what I always point out there is, for example, the energy draw with a big bed. And I think not anymore. Yeah. And this would be this is also one of the reason. Of course, I'm a Prusa shill. Yeah, I pre-ordered one.
Aren't you all? Oh, you pre-ordered one. Wow.
I pre-ordered one, yeah.
Well, which one are you getting?
I pre-ordered because I did it right when they released it, because I wanted to get one quite early. I only pre-ordered the one tool head version.
Okay.
But I'll probably upgrade to the tool print head version once they are making things ready for release. And that's what they also stated, that you can still change your configuration around. I think pre-orders have been $200 for every size.
Right. So you just put your money in the hat and reserve the spots in the queue.
Exactly. Yeah. But the reason why I was always hesitant of using larger printers for my everyday machines was because of the huge beds. In summer, it just heats everything up. It draws a lot of energy. Power is horribly expensive here in Germany. So I stick to my tiny machines, but I'm really hoping that the Prusa XL becomes my daily driver, what now my Mark IIIs are, and and probably even more efficient. So I find that kind of nice, and I think it's kind of a versatile machine. Of course, it's not released yet, and the printer can be really horrible because it has a lot of more features. The complexity with the 16 heat beds is already kind of high.
I think that's figured out. What I'm worrying more about is the extruder and the load cell, and that doing what it's supposed to do. Because that has already been a critical spot in the Mark III with the new optical sensor there.
What I'm thinking is, I guess when the machine will be releasing, I think things like jam detection and stuff like that will not properly work yet, because I think this is you need a lot of training data. You need a lot of customers and users where things are not working. I hope leveling is easy to figure out, because I guess it's kind of kind of easy to know when the nozzle touched the bed. But the other stuff, I think they will be gathering the data. But I think that this is not working properly once it releases. So and this is not a feature on what you need to rely on. The rest, Core XY kinematics is easy. The extruder, of course. Yeah. I guess that's not such a huge problem. I'm also thinking that they probably have this extruder running on the expo in Dubai. So they have tons and tons of hours and see if things fail there. I'm not too worried about that.
Well,
but the added complexity, and even though I'm happy with my Mark III and my Mark II, I know a ton of people who bought even pre-assembled Mark IIIs and had things not working properly. The mainboard was not working and things like that. So, and if you're now increasing the complexity 16-fold by 16 heated beds, there's just a higher chance that one thing might not work and might ruin everything in the end. But we'll see. I hope they figure out their QC, but this is something I'm a bit worried about.
Yeah. Well, I guess on the good news is they've been working on the XL for a while. So I remember that the load cell stuff that they've now got in the printer, they've had at least for like 3 or 4 years they've been playing around with that sort of stuff. So yeah. I guess they did have some time to figure this out, and there's always been. I remember, I think 2 or 3 years ago, there was already talk about, hey, we're going to have an XL at some point. So at that point, they were already working on things and figuring stuff out. I guess one closing note is something that I find kind of silly looking is the Prusa mini screen at the front that they've stuck on. That looks so inappropriate. I don't know. It's a little. The screen is good on the mini. Like, don't get me wrong, but the screen is tiny on the. It looks tiny on the XL, and it's just the same thing. It's taken apart from their cheapest printer and sticking it on their most expensive printer, and it's like, couldn't you have done something a bit nicer there?
If it's working, okay.
Sure.
People were complaining about not having a touchscreen on there.
I don't mind that at all.
I don't mind that either if it's working fine, but it has kind of become a standard for newer printers with all the MKS and SKR screens and whatever, that people want to have a touchscreen on the machines.
Right.
Many of these screens are not working properly and I hate them. But this is just a point where people are going to complain.
Yeah.
I don't know. I as I said to you before we started, my camera setup currently is a box where a Prusa Mini is in, which has been sitting in my office for the last months. So I have never used the Prusa Mini, and I don't even know how good the screen is or how bad the screen is and how good the whole menu system works.
Yeah. It works. It works really well.
Okay.
It works better than on the. Well, they took a couple things out, but I think it's with firmware updates and stuff. I've not used my Mini in a while, but yeah, at the beginning it was like, okay, new system, new look. Okay, we've dumbed down everything a bit. And if you were used to the old school screen on the Mark III and stuff, it did feel a bit bare bones, but it's fine. It works. It's just like what I'm saying is it looks inadequate. It just looks funny on the printer. Yeah. Like I would expect like a 7-inch tablet or something on there, and then a click wheel if you want to set temperatures and stuff. But I guess if it works.
But this is the thing again. They are still trying to have this thing available at a quite competitive price.
Yeah.
And having a screen which costs $5 on there in comparison to one that costs $50 will result in a different end consumer price. Yeah. I don't really mind that. How much are you actually working on that screen?
Yeah, you start a print, and ideally the printer does all the calibration stuff itself, so you wouldn't need to engage with that at all.
And I hope that finally the Prusa web interface properly works.
I'm looking at this. The XL does have some sort of network, right? I'm not finding Wi-Fi or network in the article at all. It does have networking, doesn't it?
They have networking. I think similar to what the Prusa Mini has, but it's not like an equivalent to Octoprint or like the Do It web interface.
Does the Mini have network? Wait.
The Mini has an Ethernet port.
Oh, okay. Can you do anything with the Mini over Ethernet is the first hit that Google shows me. Yeah, I don't know what they're doing right now. But my only experience with the network interface of the Prusas was with the SL1, and that was a status page, and that's it.
Yeah, I think status page is what they currently can do. But I have been so getting used to... So for the last months, I have almost purely printed with machines that were running rep firmware, and I so got used to just one click send the G-code to the machines, control the machines with my phone and things like that. And if the Prusa XL is not supporting a proper web interface where you can start, pause, and check on your prints, I think this is going to be bad because people will expect it. And especially if you're having companies and want to run those as in a print farm, you need a print farm management software.
From what I don't know if I'm making this up now or if this is something I actually heard, but I believe that is what they are going for as well. Well, they've got that for that Dubai print farm thing. Yeah, that's exactly what they're doing with a farm management tool, and I would assume that the XLs would be supported with that as well. Yeah. So that is something that I'm hoping they're going to do.
Yeah. It's only a logical step, and I assume they're already using something like that as a trial in their own print farm.
Absolutely.
On the Mini, something. I don't know.
Interesting. Yeah, you've pre-ordered one. I did not because I don't need another printer. The only reason I'd get one is to test it and to try it out. And I'm hoping that Prusa will be kind enough to send one over for review, or to loan me one at least. So I'm banking on that, even though it might not be right at launch date, but. Hey, here's
well,
hoping.
you have I think a better connection to Prusa than I have, but Prusa is not like spamming every reviewer with review units. I don't even think that they. So my Prusa Mini that I have right here, I won in the Polymaker competition. I think they never approached anyone for Prusa Mini reviews. Approached a ton of reviewers for Prusa Mini reviews. Besides maybe you and, I don't know, Joel. Did Joel ever? At least they never approached me. And I just thought, okay, it might be nice to have a review of the machine out pretty soon. So why not pre-order one? Maybe affiliate sales will give a bit of kickback. But seeing how many, and we also kind of did a reaction video on the on the Prusa XL, seeing just how many covered the Prusa XL pre-launch thing with their affiliate links below that, some of the market might already be saturated.
Yeah.
With people that already pre-ordered it, and that good affiliate marketing money already went to others who commented on on those promo pictures.
Yeah. With pre-orders, also with the E3D Revo pre-orders, it is making reviewing them much less attractive in the end, because if everyone has already pre-ordered, it is financially unreasonable to review them and to spend the time on that. Yeah. Oh well, but that is a whole different topic. Maybe closing this one out. Probably in spring sometime. Prusa's invited me over to see their alpacas. Maybe if you want to come, hey.
Yeah, he also already invited us or me a couple of times, but due to COVID, I never made it. But I really want to go. I really want to just pet the alpacas.
Yeah, on the Prusa Chateau outside of town. Yeah, yeah. I mean, maybe we can figure something out in spring. We can take a trip over there.
Yeah, it's not far from you.
Yeah, 3 hours.
Yeah, maybe. Yeah, let's move on. Maybe on the talk of smart features on the Prusa XL with the load sensing and the filament path. I stumbled over an article on 3D printing industry where Bond 3D was featured, which is a company that does void-free peak 3D printing. And I dug a little bit deeper. They're doing FDM 3D printing with peak, and what they're claiming is that their process enables them to print void-free, so without any porosity, so that you can use their parts for holding gases and liquids. And the interesting approach that they are doing, they also have kind of a load sensing mechanism in their machine where they measure the force that the extruded filament that's already out of the nozzle acts on the nozzle and the whole extruder assembly. And if the force is low, they know, okay, we can push more material. And at some point they reached more or less the point where like the whole gap is filled, and they are somehow able to tune in the process and also their own slicer to print void free. And seeing just the load sensing unit on the Prusa XL and all the artificial intelligence and stuff like that, all the stuff that you can do with the data that you're gathering might enable techniques and I guess in situ adjustment of specific settings to print better parts, which means void free, and therefore also increase the strength of these parts.
Yeah,
which I find kind of cool.
Yeah. So what the Bond 3D technique basically is adding, it's adding one sensor that closes the feedback loop. So traditionally in a 3D printer, you have the printer knows nothing about how much filament is actually pushing out. Yeah, it doesn't even know, like it knows how fast it's spinning the extruder, ideally, unless it's skipping steps, but it doesn't know how much filament is actually coming out. So that this sensor now, or what they're doing with the data from the sensor closes that loop. And I think it's one of the themes we're seeing more in 3D printing is that you're getting some sort of feedback, be it real-time feedback with this sort of a sensor that can control how much filament you're extruding, or by doing a one-time feedback and using that data for calibration. What's it called? Pressure advance, that sort of thing. Yeah. And what is it called for linear motion? Input shaping. Input shaping. Yeah. Where you've got an accelerometer on the tool head, and you're basically measuring what your machine is doing once, and you're then using that in a model that compensates for what your printer is doing. So just a tiny little extra sensor gives you a whole lot more input on what your process is doing. Same here, same on the Prusa XL, and theoretically, we briefly scratched on this too. Theoretically, the Prusa XL's load cell might be able to do this too, if it's not completely gimped by patents.
Yep. The challenge in the end is only how to process the data and, well, adjust parameters. But this is something that might be, well, where somebody might be able to figure that out if it's not blocked totally by patents. And there are patents on the void-free 3D printing technology that Bond 3D uses, but I think it just shows gathering data and then also analyzing, processing that data might enable the technology to just get one step forward.
Yeah, absolutely.
Speaking of multi-color tool changer printing or multi-material 3D printing, Creality, or at least Creality is somehow involved in that, because I think it's not launching under the Creality brand, but there is a Creality MMU, I think currently on Kickstarter. Sorry for that.
Yeah, I'm going to click that. It's probably going to be loud. Yep, sorry about that.
It's called CoPrint. CoPrint 3D printing technology, which is an MMU with 7 outputs. I think works exactly as the Prusa MMU.
MMU2, yeah.
MMU2. Yeah. No, it's working like an MMU2, but it is, since the Creality printers are Bowden driven, it actually should also feed the material into the nozzle. There's a box that you basically strap onto your printer, which has a selection mechanism for different filaments, and then you have one of these multiplexer parts on your machine where you can like feed filament from many different Bowden tubes into your hot end. And yeah, that thing should take care of everything. The reason why I found it interesting is the promo pictures look horrible, or the Bowden connectors on the promo pictures.
Oh, those.
Yeah, there are printed parts in there, but I think the Prusa MMU is also 3D printed, so it works.
Sorry if that was loud. Oh, there's the multiplexer. Wow, that looks wild.
Yeah, it's yeah. The multiplexer looks wild.
It's like a huge funnel that's sitting on top of your hot end.
I would imagine that thing. Oh, we can just check the Kickstarter price. What's it on Kickstarter? I would imagine that's something around $100.
$329 or more.
$329
pounds,
okay.
British pounds. So $439 for one co-print super early bird.
Okay, so I find that price ridiculous because I thought that this might be a nice option for someone who doesn't want to spend the money on a mosaic palette. But a mosaic palette is just a little bit more expensive.
I don't know how much I have no idea how much they are. Would have guessed there would be more, but
the palette is it's I think $600 starting from the smallest version. Of course, It's still more expensive, but that MMU thing, it's just like two stepper motors, two stepper motors, and a bit of electronics. I find it really.
Does it have the cutter? I don't think it does. It has the cutter from the MMU 2, right? It takes off the little filament wisps that are stuck to your to the end of your spool.
I have no clue.
Nah, it looks like it's just a one stepper motor that engages the extruder drive and the screen and a little touch knob. So for that, yeah, and of course you get the multiplexer itself, but that sounds it is quite expensive, which gets me thinking, like the £329, that might be more expensive than what it would retail for. Because there is no, I think Kickstarter is actually not permitting you to say, oh, if you buy it, you save X amount over the retail price. Well, okay, it says 20% off. Technically, Kickstarter isn't allowing that, but they're doing it anyways. But like 20% off. So future retail price would be basically $500, over $500 for the for this thing.
It still requires you to print huge purge blocks, so no advantage there compared to, for example, a mosaic palette. It might be a nice and easy option for the Creality 3D printers, but I would have suspected a way cheaper price.
Yeah, they've got a fun little comparison table here where they're comparing the co-print to the Palette 3 Pro, to the Prusa MMU, to an IDEX 3D printer and an industrial printer. User interface. Co-print has a user interface. Palette has a user interface. 5 stars. Prusa MMU, no user interface. 2 stars. Because you don't need one, because it's handled by the printer. It's, yeah. Interesting. I mean, what I do like about this project, though, is that they're just using Prusa Slicer. It's you don't seem to agree with that much, but it's such an obvious choice because it is a ripoff of the Prusa MMU with 2 more filaments. So why not use the slicer that Prusa created for that exact application? I keep saying this quite often with 3D printer manufacturers where they think they need their own slicer for their own printer, where it's like, oh, we've now got Creality slicer and Elegoo slicer, and it's just a skinned version of Cura. Why not just use Prusa slicer and submit your own profile? Prusa slicer 3.4 now has profiles for the Voron baked in for all the different Voron sizes, which is really cool.
I've seen that.
And you can do that like they are doing here. Just add your own profiles and there you go. You've got a world-class slicer for free. With Prusa branding, obviously, but hey, it shouldn't be a surprise that it is basically a Prusa MMU 2 that's being copied here. Is there any other option of adding an MMU 2 style setup to your printer? Is there like a universal MMU that you can add to an ender?
What's the MMU thing that works on the Voron? So Nero 3D has been playing around with a thing I've seen on Twitter for
the
quite a while.
Enraged Rabbit Carrot Feeder.
Maybe.
I think that's it. Yeah. Oh, AliExpress. Oh, you can get a kit on AliExpress of the Enraged Kaninchen Karotte Feeder, which has 5 outputs. It looks like it has a cutter.
Yeah.
Or is this a cutter or is this a filament, a Bowden tube offsetter? I'm gonna drop the link in our show notes here real quick.
Yeah.
There we go.
How much is it? Oh, that's just
150 bucks with the motor. Oh, you can get it with size 9. Is that 9 filaments?
Ooh. Yeah.
170 bucks. That's pretty good. But of course, you don't get any support, any software. You have to. Oh, and it doesn't include printed parts. You have to figure it out yourself, basically.
And I guess it's only working for direct-driven machines. But yeah, there are options. There are not many. But yeah, at that price tag, I find it a bit expensive.
On the, what's it called? The color print, co-print, yeah. Yeah, and of course, it's still a multiplexer system with all the ups and downs of that. Of course, you have no calibration that you need to do. But you are wasting a lot of filament on just printing priming towers just to get the old color out of your nozzle. You have the problem that the retract cycle on the filament is really finicky. If you don't do it right, you end up with like long strings on the filament that can end up clogging the filament path for others. And yeah, you have quite long switchover cycles because you need to retract the filament all the way out of the hot end and back to the to your SEPTA extruder, to your 7X extruder. No, actually, you just need to extrude it. You just need to retract it out of the multiplexer, right? But still, with that, with priming, with the cycles for that, it does add time over even a tool changer or an IDEX printer. I think IDEX printers are still very much a valid choice if you just need 2.
Yeah.
But yeah, comes with its downsides, comes with some upsides. Upside obviously is you can use it with any printer. But yeah, interesting concept. And people seem to like it. It's already funded at 121,000 euros out of their 8,000 euro goal. So that was probably like $10,000 or something.
Besides somebody, I guess, emailing me that link, I haven't seen it featured anywhere. I'm always asking myself if there are services where you can buy Kickstarter supporters just for promo, but
yeah, so you can have maybe funded in 2 hours.
Funded in 2 hours.
Yeah, classic. Let's not make any unfunded accusations. Yeah.
No.
Let's shoot a couple of questions, and I think then we can wrap this one up. We're already getting quite long.
Yeah.
So this one is from Twitter, from Mr. Unbekannt 2.0. Hello at the Meltzone. Is this some kind of new 3D printing technology or just an optimization of existing technology? And I assume he is sharing a link to BR Automation, where they have a process that basically, so that they're saying they are combining the advantages of injection molding with 3D printing. So what they're doing is they're 2D printing individual layers, and then they're fusing those cutouts or prints essentially to each other to make a 3D model, which is pretty cool and pretty novel. Not completely novel. I've seen sort of a process like that before, where the printer uses inkjet paper, printer paper, cuts it out with a drag knife, and then stacks it on top of each other with like a spray adhesive or something. But this is actually doing 2D printed layers and then stacking those on top. Have you seen that before, Stefan?
I've only seen like the paper thing.
Yeah.
But yeah. Another one of these processes. Not sure. It's kind of sad. Maybe things like that would have been like presented at Formnext. It's an interesting concept. I guess it always depends what materials you can use, what the end properties are, and if it is really 10 times faster than an industrial 3D printer. Because, for example, SLS 3D printers are already really fast. I know that EOS is working on a matrix laser SLS printer. So instead of having just one laser beam that exposes a layer, you have basically a laser array where you have a print head that is, going all over your powder bed and really fuses those layers together very fast. And for example, the HP multi-jet fusion is also really fast with the binder, and then just a quick swipe with the lamp to fuse everything together. So
I guess if you have rigid 2D layers that you're stacking, you're at least enabling some new geometry options without using support materials. So overhangs, at least like perfectly horizontal overhangs, wouldn't be a problem anymore, because you've got one rigid layer that you just stack on top of the other. You're printing that onto a separate bed and then stacking that. So pretty cool. And also, if I don't know how this process exactly works, but what you could do is you could add parallelization to this. So 10 times faster, just use 10 printer mechanisms that print one layer at a time, and then use the next one, use the next one while the others are already printing again. So that definitely could speed things up.
Yeah. The question in the end is if this is feasible for also like very tiny details on parts. I know that one really efficient metal 3D printing process, or actually sintering 3D process, is using, for example, screen printing, where you screen print layers on top of each other, because
and then you have
screens are.
You have a custom-made screen for every layer?
Screen for every layer, exactly. So this is only working if you have really simple geometry. It is nice for if you just have an extrusion profile, but I don't really know what the point of all of that is. But there are kind of efficient 3D printing process that in the end turn out only work for a very small range of parts and details.
Right. But to answer the question of Mr. Unbekannt, is this some kind of new 3D printing technology? Yeah, pretty much. Neither one of us has seen it, so I would check that box for Nozzle, at the very least.
So, Stefan Daurer has been asking on YouTube. Hardware thermal fuses like the ESKA 77110 in the bed should be mandatory in sold printers, just in line with heater heat bed. He says that you shouldn't only rely on software thermal runaway protection. Why not include thermal fuses on, heater beds and also on heaters themselves? I have seen a thermal fuse on my Voron Zero, where a 125 degrees thermal fuse is installed, but I haven't seen any other printer so far where this concept is applied. Question is why?
So same on my Voron 2.4, also has the thermal fuse on the bottom. I think that's just standard practice for the Vorons. I think I remember seeing thermal fuses on like the very early hot ends that people were building before heater cartridges, when you were still wire wrapping a resistive wire around whatever brass thing you drilled up yourself. I think at that point, sometimes you were seeing thermal fuses, but of course the size is a bit, it's a bit drastic for a hot end if you have that block that you have to chuck or attach to it somewhere. Why are they not being used more? I mean, for a hot end, really, it's there's no real downside to using it except for the cost and the extra effort. But also, is it worth using it on a hot end or on a heated bed? Unless you have a powerful heater like on the Voron, where stuff can go wrong very quickly. Even on a You would need to have a double fault in that case for it to make sense. So on a regular PCB heater on your cheaper printers, even if you continuously power the bed, it's not going to get any hotter than 140 degrees maybe, because your temperature dissipation from the bed is just so large compared to how much energy you're putting or how much power you're putting into it, that it physically cannot get any hotter. So the only ways for that to fail would be with what's usually called a double fault, where first the firmware doesn't catch the error, and second of all, there's some way where there's more power applied to the bed, like, I don't know, a mounting spring shorting out a track. That has happened before, and all of a sudden you don't have a 1 ohm resistance, but a 0.5 ohm, and it draws double the power. So that's already two faults that are happening. And very often in consumer electronics, it's like, well, double faults is not something that we should be concerned about because, like, you know, either one should be caught, and that both happen at the same time is very unlikely. Depends on the individual case, of course. But I think for most cases, it's just, well, it's either very unlikely that this would happen, that you'd get a runaway, or the consequences would be very non-dramatic. On a hot end, depends on the setup, of course. Some hot ends are also quite underpowered, but as we've discussed last time, a Prusa can melt a heater block. So if you could have a single fault there if the thermistor doesn't read well, or if there's something wrong with the firmware gets stuck, you could potentially melt down your heater block and bad stuff to happen. So I think at that point it's really just is there a thermal fuse that is small enough to be integrated into a hot end? I mean, what's you entertain the audience a moment. I'll try to find a thermal fuse here.
Well, you basically would need to include it into the heater cartridge, because you have to reroute, or you kind of have to reroute the power through the fuse somehow and then back into the heater cartridge. I guess the thing is, the heater cartridge, I guess, definitely gets warmer than, for example, 300 degrees Celsius, because there needs to be a temperature gradient, especially during heating up. In my opinion, yeah, of course, it would be a good thing if something like that would be the standard. But maybe the better option is to just switch the heating elements themselves, like E3D is now doing with their ceramic heaters that just inherently don't get any hotter than a specific temperature. I think this would be the better option. The thermal fuse is just a walk around where you would need the double fault.
Well, I mean, in some cases, fuses, like electrical fuses, they're there because it basically takes up, or it when something else goes wrong, the fuse is the thing that catches that, and it's the only thing that catches that. In the 3D printer, you already have a system with the thermistor, right?
Yeah.
So I'm finding microthermal fuses here. They do exist. They look like they're about the size of a thermistor cartridge. However, either they're not rated for DC, which I guess at 12 volts it's not really an issue, but there can be an issue with arcing in DC applications, where the AC always has a zero cross, so the arc gets extinguished automatically. So either they're not rated for DC, or they don't have the temperature range they would need. So all the ones that I'm finding top out at 240. 240 maximum open temperature and 200 degrees holding temperature. I guess they're based on a polymer typically, and not some bimetal strip. If you had some bimetal assembly, I guess you could go higher in temperature, but then you obviously add size. You add a lot of size. Yeah. But those smaller thermal fuses, 240. That's all I'm finding.
Yeah. And maybe somebody has pictures of one of the like really 10-old self-wound hot ends where something like that was implemented. As I said, I would prefer just having a heating element that can't exceed a specific temperature let it be 350, 400 degrees Celsius, which is still fine and would not cause any burning or melting.
Yeah, you will get a lot of smoke. Your plastic will not be happy, but yeah, you're at least preventing stuff from melting down.
Yeah. All right.
Yeah, so Jesus, I kept looking here, but they don't seem to exist at that temperature range.
Yeah.
And last question for today, from Hatfield Flightcraft. Love your podcast. I have only just started and I'm working my way back through your older content. I'm wondering how view count impacts your income. I've been only consuming the audio through Google. I'm getting exhausted. I've only been consuming the audio through Google Podcasts and would like to make sure you two get the most credit for my consumption of your content. I will start streaming from YouTube and listening with the screen turned off if it is more beneficial. Please keep up the content here and on the individual channels. So thank you, Hatfield Flightcraft. Stefan,
I checked our stats.
You checked the stats? Which ones?
Check the stats. Oh, I don't know. What did you want to say? I checked the stats, and for the 12 episodes we did this year, we had an ad revenue on YouTube, which was $500 before tax.
Yay.
So the podcast doesn't pay the bills.
Nah, it's so if it was a pure effort to revenue, like we would be doing this. Except for, I mean, maybe we have a sponsor or two every now and then. That does bring in a bit extra cash, but of course we split that 50-50 between us. So yeah, but YouTube is the only one that's paying. Yeah. Audio streams through Google Podcasts, Spotify, Apple Podcasts, whatever other platforms build on that, zero, nada. You might see ads on Spotify or wherever, but that ad revenue goes to Spotify or to the platform exclusively, and we see zero of that.
Yeah. So don't worry, listen with your podcast app of choice. It won't make us more poor or more rich, depending on what you're choosing. I guess that's fine. Yeah. And if you want to support us, of course, there's Patreon. We can now activate channel memberships. We probably should take a look at that.
Did we talk about this last? I think we should, yeah.
Yeah, I think we talked about that last time. Yeah, and maybe you need to deal with one or the other sponsor spot in one of these podcasts because they are rather paying the bills. Then the ad revenue. And of course, if there are affiliate links below the podcast, they also help us out. But choose what is most comfortable for you. And if it's the podcast player, that's totally fine.
Absolutely. Right. So with that, thanks for listening anyways. Yeah, it's fine. We're doing this because we get to chat about cool stuff, and maybe it gets people onto our main channels. If that's like the only way we can make revenue off of this, basically.
And it kind of keeps us also sane from time to time. If you're just doing too much in your own bubble, in your own studio, talking to somebody like-minded is kind of nice. Absolutely. As well.
I do enjoy this very much. So with that, Stefan, thank you for taking the time today.
Thanks for your time, Tom.
Thanks everyone for listening, watching. Like I said, if you want to support us, you can do so on Patreon or through the channel memberships, either I guess on this channel or on our individual channels. But just like watch our stuff. Give a thumbs up, subscribe. That's more than we could ask for. Hope you enjoyed, and we will see you all in the next one. Bye-bye.
In the next one. Bye-bye.